Okay, good afternoon class. Okay, today we are going to talk about 2.2.4.2 summation of an infinite geometry series, or we call it the sum to infinity. So when the number of terms n of a geometry series is very large, it is n approach to infinity, then the series is called an infinite geometric series. So these are two examples for the infinite geometry series. Means that it won't come to a stop. Okay, the terms will continue. All right, let's consider the first infinite geometric series in A, which is 1 plus 3 plus 9 plus 27 plus 81 and so on, where the first term A is 1 and the common ratios R is 3. So when we sub these values into the formula of sum of the first n term, all right, which is A r to the power of n minus 1, r minus 1. So after we simplify, we get this, which is 3 to the power of n over 2 minus half. So let's see, when n approach to infinity, this term, 3 to the power of n, will approach infinity too. Therefore, the sum of the first n term will approach to infinity. So the limit for sum of the first n term when n approach to infinity is equals infinity. So we say that the limit does not exist. So this series is said to be divergent. Still remember divergent, right? So means that the sum of the first n term when n getting bigger and bigger means we include many terms, then the sum will become a very big number. Okay, now consider the infinite geometry series in B, which is this one. Alright, so you see that for this geometry series, first term A is 1 and common ratios R is half. So again, we sub these two values into the formula of sum of the first n term. So after we simplify, we get this. Alright, it's 2 multiplied 1 minus 1 over 2 to the power of n bracket. So you see this, when n approach to infinity, this term 1 over 2 to the power of n. Alright, so 1 to infinity is 1. 2 to the power of infinity is infinity. So 1 over infinity approaches 0. You see that this part will approach to 0. So when this part approach to 0, so 1 minus 0 is 1. So 1 times 2 is 2. So it means that the sum of the first n term is approaching 2. Or we can write as the limit of the sum of the first n term when n approach to infinity is equals to 2. Or we say that the limit of sum of the first n term exists. So this series is said to be convergent. So we say this infinite series converge to the sum 2. And the limit 2, we call it sum to infinity. Or we can represent by the symbol S infinity. Therefore, the concept of limit for the sum of the first n term, when n approach to infinity, we can represent it by a symbol S infinity, which is equals to 2. So you can refer to an example in your textbook, page 121. Alright? Okay, then go to the next page. So in general, for a sum to infinity to be exist, so let's see these two examples. So if the common ratio, modulus of a common ratio less than 1 means the value of the common ratio is between -1 and 1. And when n approach to infinity, because r is between -1 to 1, so when it's to the power of infinity, r to the power of n will approach to 0. So let's look at this formula for sum of the first n term. Alright, so the limit when n approach infinity will become like this. Alright, and we write it in this form. Okay, either we use sum n equals 1 to infinity, or we write it in the limit form. Same. Alright, so since just now we say, right, 1, when r is between -1 and 1, r to the power of n will approach 0. So means this term will approach 0. Alright, therefore, the formula for sum to infinity become a over 1 minus r. So remember this formula. Okay? Okay, what happens if the modulus of r more than 1? Or more than 1 means either is less than -1 or r is bigger than +1. So when this happens, when n approach to infinity, r to the power of n will approach infinity too. So when r to the power of n approach to infinity, right, then the sum of the first n term will approach infinity. So the series does not converge, or we say it is divergent. All right, so remember the basic concept is for a geometry series, for a sum to infinity to be exist, the modulus for the common ratio must be less than 1. Or we write it that r between -1 and 1. Okay, and the formula is a over 1 minus r. Okay, is that clear? All right, so let's see some example. All right, example 2.2.4.2. Okay, look at the first question. So the question says, find the condition satisfied by x so that the sum from r equals 0 to infinity for this general term, x minus 1 to the power of r over 2 to the power of r, to be converged. All right, so remember the variable is r. X is a constant, it's a number that we do not know. Right? After that, we are asking to evaluate this expression when x equals to 1.5. Okay, so the solution will be like this. Okay, so the question tell you that it's a summation for this general term from r equals 0 to infinity. So we sub in a few values of r. So when r equals 0, 0, 0, so the first term is 1. So when r equals 1, so the second term is x minus 1 power 2. When r equals 2, so this is square, and so on. So it's very clear that it is a geometry series with first term 1 and the common ratio is x minus 1 over 2. Right? So the question says, find the value of x so that it is converged. So the condition for a series to be converged, this is a condition, right? The ratio, the modulus of the common ratio must be less than 1, or we use this one. Okay, so the common ratio is x minus 1 over 2. So sub in. All right, so move the 2 to both sides, you get this. And move the minus 1 to both sides, you get this. So means that x only can take values between -1 to 3. No equal sign, no equal sign. So x can take any values as long as it lies between -1 to 3. Then this series, the sum to infinity will be exist. Okay, so this is what the question means. Alright, then the question says, sub the value x equals 1.5 into the series and find the answer. Alright, so 1.5 lies between this range, so it's okay, can be used. So when we sub in x equals 1.5, alright, as I say, from here, we know that it is a sum to infinity. So this summation is actually equals to sum to infinity. So we use the formula for sum to infinity, which is a over 1 minus r. So sub in all the value, a is 1, common ratio here, x minus 1 over 2. So sub in here, and your x is 1.5. So you get that the answer is 4 over 3. Means that when x getting bigger and bigger, when you add up all these terms, the answer is actually approaching 4 over 3 only. Because each terms will be getting smaller and smaller and smaller and smaller, but never come to 0. Therefore, it approaching to 4 over 3. Okay? So question 2. Look at question 2. The question says, the third term of a convergent geometry progression is the mean of the first and second term. Okay, let's put it this way. Okay, question 2. Okay, so this is the meaning. The third term is the mean of the first and second term. Means this one. Third term is the mean. Mean means U1 plus U2 over 2 lah. So this is the information given. So find the common ratio, find R. And if the first term is 1, find the sum to infinity. So we just use a formula for the term of a geometry series, right? Which is URn minus 1. So third term is UR3 minus 1. First term is A. Second term is UR. So we factorize A. So can be cancelled out. So I get a quadratic equation. So after I factorize, I found 2 R's. Alright, so we know that the definition for geometry series is R cannot be equals to 0 or 1. So we reject this answer. Therefore, your R is equals -half. Alright, so when R is equals -half and the first term is 1, therefore the sum to infinity, sub into the formula. This formula, A over 1 minus R, which is equals to 2. Okay, so this is the second question. Alright, so the next one that I'm going to discuss is question 5. Alright, questions 5. So questions 5 say, express the recurring decimal 0.45. See, on top is dot dot. This 2 dot dot has meaning, later we see. So you're asking to express this decimal as a fraction in its lowest terms. Lowest term means in the simplest form lah. Alright, so what is the meaning of recurring decimal? So this is the meaning of recurring decimal. It's 0.45 and you see 2 dot dot on top. So the digit with the dot are the digits that going to repeat. So means that this 0.45 dot dot means 0.454545454545, infinitely. So how we convert this decimal number into a simpler fraction? Alright, so we are using, actually got 2 methods. Okay, so we are using the geometry series method now. So 0.45454545, I actually can split it, become like this. Right, 0.45 plus 0.0045. This 0 is actually this 45 lah. Then plus 0.000045 and so on. Right? And you see that each one is with 45. So I can factorize out 0.45 actually. So it become 1 plus 1 over 100. Because 0.45 divided by 100 will be get this thing. Alright? And this one. So it's very clear that, so 0.45, I write it in a fraction way. And this one in the bracket is actually a geometry series with sum to infinity. Alright, so this sum to infinity, the first term is 1 here. And the common ratio is 1 over 100, right? Each time multiply 1 over 100. Okay, since this is sum to infinity, we use the formula for sum to infinity. 1 minus 1 over 100 is 99 over 100. So divide reverse lah, become 100 over 99. Simplified with 45 over 100. So you get 5 over 11. So you can check with the calculator. When you use 5 divided by 11, you will get back this decimal. Alright, so this is how we express a recurring decimal into fraction form. Okay? So you see that actually we have a few past year questions which involve this recurrent decimal. Alright, so you can try question 3, same, and you see STPM 2003 in Mathematics M. So look at this. It's 0.1318. Only 18 has dot dot, means it's only repeated 18. It shows the example here. Alright, and in Mathematics T STPM 2007, you see, it came out again. Alright, so this is not repeated. 0.7 is not repeated. So you just put it outside. Means that you add 0.7, then plus 0.025 and so on. Alright, the 0.7, you can write it as 7 over 10. Then later add it to the sum to infinity. Oh, all right. You see, question 8 also another question which involve the recurrence decimal. All right. Okay. So we will discuss one more question, which is question 11. All right. Question 11. STPM 2002. Right? You're asking to determine the set of X such that the geometry series, this geometry series, will be converged. Then find the exact value of X so that the series converge to 2. All right. Okay, so the solution is like this. So this is the geometry series given. So it's very clear that this is a geometry series with the first term 1, and the common ratio is e to the power of x. Each time multiply e to the power of x. So for this series to be converged, the question asks, so we know that for the series to be converged, the common ratio r must be between -1 and 1. All right, so we are going to solve this one to find the range of values of x. So, but we also know that for all value of x, ex is always positive. Okay, it cannot be negative. Therefore, we only solve ex less than 1. All right, this one we can omit. So we add ln to both sides. So x put in front, ln 1 is 0. So we find that the set of value of x is x less than 0. You see, the questions ask you to determine the set of x. So the final answer must be in set notation. Also means that for this series to be converged, x can take any values as long as negative, less than 0. All right, then the second part is find the exact value of x so that the series converge to 2. The series converge to 2 means the sum to infinity equals to 2 lah. All right, so this is the formula for sum to infinity, a over 1 minus r. So when you solve this equation step by step, you found that your x is equals to negative ln 2 because it's actually ln half. So ln half, 1 over 2. So 1 over 2 I can write as 2 to the power of -1. So become ln x equals negative ln 2 lah. So when x take value of negative ln 2, then this geometry series, the sum to infinity will approach to 2. All right, so these are the questions related to sum to infinity. All right, so now what I want you to do is, I'm giving you about 15 minutes, 1-5, okay, 15 minutes. I want you to complete question 8 and question 12. Now, all right, finish it and then snap the photo of your solution and upload to the Google Drive that I have sent you the link. So means after 15 minutes, every one of you must forward the solution of these 2 questions to the Google Drive that I forward to you. All right? So after 15 minutes, I will send you the link of another video. All right? Okay, you may start now.